In this example, we are going to look at exponential decay. The average car depreciation rate is 15% per year. If you purchase a car for $19,000, what is the approximate value after 8 years? So a car depreciates, meaning that it loses value. So if it's losing value, the price is decaying. So we're going to set this up first as a function. So we'll say y equals, and the initial amount is 19,000. And then because we're depreciating or we're decaying, it's going to be 1 minus the rate. So the rate is 15%, so we'll change that to 0.15. And then the time is 8 years. So let's just simplify it a little bit. So we have 19,000, and then we have 0.85 to the 8th. So we're just going to plug that into a regular calculator and solve for y. So y is money. So we have $5,177.32. Okay, so here a population of 1,860,000 decreases 1.5% each year. So first thing that we're going to want to do again is to write a function for this. So we're starting with our population, which was 1,860,000. And we are decreasing, so 1 minus 1.5%. So that's going to be 0.15. And we don't know the time, so we're just going to say it's to the t. So I'm just going to clean it up a little bit. So 1,860,000 times 0.985 to the t. So that's the function that we're going to be working with. Now, part B of this says to find the average rate of change of the population between the 2nd and 4th years. So first thing we want to do is we want to find what the population is after the 2nd year and after the 4th year. So we're going to plug in. So when t equals 2, y is going to be 1,860,000 times 0.985 to the 2nd. So we're just going to plug that in the calculator, and it's going to give us 1804618.5. So just plug that in the calculator and get a population. We're going to do the same thing when t equals 4. So we're just going to take that 1,800,000. Okay, so when you're doing this in the calculator, if you're going to type in exactly the way that it's written, just make sure you use parentheses. If you're going to do it in pieces, what you're really doing is taking 0.985, raising it to the 4th first, and then taking that answer and timesing it by 1,860,000. So what we get now is 1750885.984. So we have our populations in the 2nd and the 4th years. We want to find the rate of change. So rate of change is the change in y over the change in x. So we would take the difference of the two y's. So it's going to be the newer one minus the older one. So 175 is going to go first. 0885.984 minus 1804618.5. The change in y divided by the change in x. So new minus old over new minus old. So if we subtract it, we're going to get negative 53732.52 over 2. And this makes sense that we have a negative value because it's decreasing the population. So the rate of change, it's changing negatively because it's decreasing. So when we divide it by 2, we're going to end up with negative 26,866 0.26 people. So the population is decreasing between those 2 years by negative 26,866.26 people. So let's look at this problem now. So we want to determine which situation best matches the graph. So if we look at the graph, based on the shape of it, because it's from right to left, it's declining, we know this is going to be a decrease. So if you look at the answer choices, B is increasing. That's the only one that's increasing. So we know B can't be right because it's a decreasing function. If we look at the different percentages of decreasing, so the population of 120 decreases 98.75% yearly. That means that it's going to be a very steep decrease. And if you look at the graph, it's not that steep. So C is 115 cougars decreases 1.25% yearly. That predicts a slight decrease. And D says 115 cougars decreases 50% yearly. So again, if it's a 50% decrease, it's going to be a lot steeper than what the graph shows. So since it's not a drastic decline, so that means there's going to be a low percentage. So that makes C our answer. And then what does the y-intercept denote? So y-intercept is going to be, in this case, right here, which is 0, 1, 15. Because based off of that we chose C, the population of 115 cougars. So it's starting with that. So what this means is when the study started at time 0, because when the study starts, the time is just beginning. So that's when time equals 0. That there were 115 cougars. So make sure that you can interpret the y-intercept for these application problems. All right, so let's look at one more. So which function represents the value after X years of a new delivery van that costs $25,000 and depreciates 15% each year? So we know that the initial amount has to be $25,000. So we should get rid of A because it's written in the incorrect way. Remember, we have y equals A, and then I'm going to put plus or minus R here, because if it's a plus R, it's a growth. If it's a minus R, it's a decay. And so for B, we have that 0.15 goes inside the parentheses, but we know that it depreciates 15%, so the R is going to be the 0.15, but then we don't have anything, we don't have a 1 plus or minus it, so B won't work out. And then for C, we have the 0.85. That means that that must have been 1 minus R. And for the 1.15, that must have been 1 plus R. And since it's depreciation, that means that we're using the decay model, and then we're going to use the 1 minus R. So then C would be our answer.